Okay, here we go. Put that Chromebook away, sir. I don't trust you as far as I can throw you. All right. Uh-huh. Close it. Okay. Shh. Actually, I got that in the start of the video. I'm going to share that at home. He was yelling at me. Okay. Yep. Yep. Here. Here. Say it louder. No. Okay. All right. It's a good start to the video. Okay. Right. This is kind of embarrassing how easy this is. Again, false sense of security, but also hopefully starting off with a positive grade here as we do this simplistic just reading of graphs chapter. This is the last section. We'll take a test, if I could even call it that, on Wednesday. As far as shortness of the time that we've been in this chapter. But anyway, this actually ends the way we started. Great. Hold on a second. Finally got it to move. Then we'll probably see. There's my scratches when I was trying to draw. They just randomly pop up somewhere. I'm going. Just hold on. Okay, just give it a second. Okay, there we go. All right. Computer is ready to go, apparently. Okay, and I think the first two go together, but going back to the easiness of starting this year off. Just rejoice in it, and then just be ready for it to ratchet up a little bit more. And many people are doing their work, and just keep doing that. So, all right, and actually, the picture to share with that is what I started off the chapter with. This is in the very beginning of the chapter, first or second page of chapter 8. The very first thing I showed you, because I thought it was a good point to open up the chapter the book used. Watch out how that graphic is presented to you. It could be distorted or put in a way where it shows something more exaggerative than actually what's going on. So these are the same two graphs, but a manipulation of scale, where you start at 6 billion to 10 billion on the left side, as opposed to 0 to 10 billion on the right side. And those two images project at least something different. The one on the left projects a major increase over the years, as opposed to a gradual increase, the one on the right. So, I don't know, I think that's just a good point being made there. Reversing of axes, they do have some examples of that. That's real manipulative. Switching the years around, going from 2003 to 1999, if someone didn't read the bottom, didn't read the x-axis per se, then it makes it look like it would be decreasing. That is a major naughty thing, I think. All right, and I think this is kind of the same thing. They do separate it, though, and I guess they use the word cropping, looking at it further with line graphs. So cropping is just like what we just had in the last example with the bar graph, where you extend or shorten the scale of an axis to exaggerate what something is doing. Smaller or larger window can make a trend more or less impressive. And then one example that I pulled as a picture out of the book was this stock price of a particular stock, nothing specific, starting at 140 in January. And then by May, it dipped to 100 and then started rising a little bit. Actually, that is pretty significant loss. First hour we calculated what's the percent loss from 140 to 100. We found out it was almost 30%. It was like 29%. That is a significant loss in value in a short amount of time. So maybe the one on the right should be used, because if you own that stock, you're taking a real big hit. Real big hit. So, but anyway, knowledge, understanding. If someone that was part of the company would show the one on the left, oh, we're not doing so bad, look at that. It's only going down a little bit. Depends what's trying to be projected, I guess. Okay, I'm going to hit resume and then see when this... Okay, it's happening again. Day in the life of Mr. Samuelis at Lockport Technology. All right, we'll press pause. Okay, third one. Finally got it to work. I got an escape plan for when the computer doesn't act right for that particular problem that I run into of many in this new computer. Three-dimensional effect. I don't know if this is the greatest picture of it, but they do make a point and a couple valid points. There's another one where they do a line graph, but they use rectangles, and it's kind of like a half bird's eye view, and it's hard in a three-dimensional graph to see where the points actually graph out to be. And this kind of is like this. You're kind of looking down on this on an angle, because this is a three-dimensional box, at least it's an attempt to. And then this line is supposed to be kind of like floating out there. And then these are the data points, these little lines. And it's really hard to see where those lines graph vertically. You know, where's that last one? I mean, where I just hit it right there, it looks like it's at 50, but actually it's not. So when you use a three-dimensional image, it distorts the vertical axis and where that's actually graphing to. So that's what they say there. And then they had another good example of a pie graph too. I see this all the time. Not that you have to write this, but just be aware of it. If you have this simple two-dimensional pie graph, if you make it three-dimensional and then have this thing pulled out and up to exaggerate that green pie piece for your presentation, you're actually exaggerating its value. Even though you might have the value written, remember the whole purpose of the beginning of this chapter was the value of pictorializing data. And what happens in our brain is we look at the picture more so than the numbers and what they represent, or at least most people, if not all, understand bigger pictures as opposed to numbers in relation to each other. And that's the idea there. Then this is the last one. This is my favorite. Instead of using a bar graph, replacing the bar with a picture, but then showing something rising or falling. So there could be a lack of scale, or it could distort the scale. This is why this is my favorite picture from the book. Items may not actually be proportional to what you're trying to represent. So as you look at these two, you could read, as a math person, what's happening with the sales from 97 to 2003. What would be a good number to say what happened with them? Doubled. Okay, good. So at least you're looking at the math. But do you know what's happening pictorially? When you double the size of the length, you know how you do this on computer. You hit it and it takes a picture and you pull a corner and it expands it. Okay, you're not doubling the size of this milk carton. This milk carton is actually 8 times the size as this other one. Huh? It's a simple volume question. If I double the heights, so I double this height, right? I also double the width and the length. And actually what that does, through simple math, isn't volume length times width times height, right? You doubled the length, you doubled the width, you doubled the height. 2 times 2 times 2 is 8. This milk carton is actually 8 times the volume as the other one. Again, pictorially, someone might be more impressed with that and think it's much larger growth than there actually is. And that's the idea of the, be careful with taking numbers and putting them in images, or at least as a person looking at them, be smart enough to understand it's really about the numbers, and these images could be deceptive. And that's all I got to say about that. I think it was a really good point, and it kind of piggybacks with all the other stuff.